Can I 3D print a few parts, take a basic 5-gallon bucket, and make a horizontal centrifugal dust separator similar to the Harvey Pro Series ones? I mean, this is like 20 bucks worth of PLA. If this works, it'd be awesome. Well, let's find out. My name's Corbin Dunn, and in this video, I'm going to start some explorations into better dust collection systems at affordable prices. And the reason I'm going into this is because I have a typical bag-style 3 horsepower grizzly dust collector, and they're going to eventually kill me with cancer, and I don't want to do that. My prior solution, which I talked about, was to put it into a closet, and that worked to some extent. Some dust still escapes, and the small filter, the area where it would actually go out into my shop, was probably just too small and would eventually overload. Now everything I'm doing here and all the files I've created for printing will be available for free. I'll have a link down in the description. So it's time for something new. So my quest led me to Capturing Dust, a really cool YouTube channel where the guy has made a centrifugal dust separator, and that is based on a design by Pilsen Guitars. Now Pilsen Guitars, his design is based on one done by someone else named Underdone, and that design is based on the one by Harvey Woodworking. And these are a really cool design, and I was really set on making one, but I have a feeling that the impeller design will tend to clog with the type of long stringy chips that my CNC generates, because I get clogs on the impeller intake on my dust collection system when I do certain types of upcut cutting on my CNC. And then if you go look at Harvey's latest dust collectors, the Pro models, they're different. And I noticed a few things about the new design that's really interesting. One of them is that it looks like it has a large single chamber, almost the size of a bucket, and also it just dumps into one dust collection container. You don't have to have 2 separate ones like the previous design required. So I set about designing my own version in Autodesk Fusion. And the way this works is there's this cyclone top portion which will simply snap onto a 5-gallon bucket. And if I hide the top and the bucket chamber, inside there's going to be an adapter which will let the dust drop down into whatever container you want. And there's this baffle thing which probably helps with the flow of the dust a little bit. And we can look at a section analysis to see how this would work. So air is going to enter in on this upper side. It will create a cyclone with the spiral, and it's going to spin around in the chamber and drop out this hole here. The baffle will kind of help prevent some of the dust from going back out, in theory, and then clean air will go out the middle port. Okay, so one of the things about this project is that I have a pretty large bamboo printer, and I maximized the size of the print that I could do with it. I printed the cyclone intake upside down because I wanted the cleanest part of the print to be on the inside where the air was flowing. When designing and printing things with an additive process, you have to be really aware of where you might have problems. And overhangs are problematic, so I printed this other portion for the air intake to be a separate piece that I could simply glue on. The back diffuser or dust separator portion is just a plate shape, and I used supports to make it, which was kind of a pain to remove them all, but I think this was the best option. An alternative way that I printed it was vertical split in half, but then I had to glue the 2 halves together, and due to layer separations, it just proved not to be very strong. The dust outlet portion was a lot easier to print, and I used it as a template to kind of mark on the bucket where I wanted to cut the hole out. And a lot of this is just me doing quick prototype work. I want to see if the idea will work out. And so I just used some glue and some tape and a little bit of caulking to attach this to the bucket. For the dust block or baffle thing, I just used a wood screw and a little wood block to screw it onto it. And then I could go ahead and screw the back side to the center of the bucket from the back. And this is just one way that I came up with to attach it. Maybe a long bolt would work better. Now I should have used a clear bucket, but since I didn't, I wanted to get an insight into what was happening. So I just cut out a small portion of the bucket and then taped on a little piece of clear polycarbonate so I could see what was going on. Now, all cyclone systems need an airtight seal to their dust outlet, and if you don't do this, it will disturb the vortex, which will make separation not work well at all. And since this is just a test, I didn't want to cut up my metal lid and destroy it, so I made one out of wood and just used some foam in between that and the lid and clamped it down for testing. And then I could caulk and screw down the actual outlet from the drum. The cyclone inlet has a satisfying click as it goes onto the bucket lid, and this way I could easily remove it and get a pretty tight seal. I probably should caulk it if I was going to make it permanent, but I just decided to click it on and go with that. So I attached a few hoses and started doing some tests. I zoomed in on the outlet because we really want to focus on anything that might pass through and get past the separator. Now, I was sucking up over 1 kilogram of dust in less than 10 seconds, and for the most part it worked pretty well, but I could overwhelm it and see some dust coming through the clean air port. I'm pretty excited because this idea seems to work pretty well and uses some really cheap materials. But there's a lot of room for development and things that need to be made better. For instance, I will see dust start to collect at the bottom of the chamber here when it tends to get overwhelmed, and I think that's a problem that needs to be solved. The actual intake shape also needs some development work. Right now, the intake's a perfect circle. That's exactly 1/3 the diameter of the top of the bucket. And instead, it seems like a lot of cyclones have a long oblong shape to help the dust get to the edges of the actual cyclone as it starts spiraling. And that would work a lot better for something like this. Another consideration for my shop is that I am designing everything around a 6-inch pipe. And what I'm testing with is a 4-inch pipe. And the amount of area that you can fit through a 6-inch diameter versus a 4-inch diameter is just a ton more. And so really a design like this where I'm testing with a 4-inch pipe, it really needs to be larger and have a larger area. And I think the way that I was going to solve that was to have dual cyclones. So testing with dual cyclones might instantly give me a lot better performance. So where do I go from here? I started thinking about the design of this and how it would work in my shop. And I feel like horizontal cyclone separators work really well for a shop that has a low ceiling because you can spread out the distance horizontally. However, my particular shop has more vertical space than it does horizontal space. My floor space is at a minimum, but I could go up in the air. I also feel like this design is working against gravity, and a typical vertical cyclone will utilize gravity a lot better for separation. So my next ideas are going to be with regards to 3D printing a typical vertical cyclone. But I really think this has a lot of potential, and if people are really excited about this video, I will come back to it and try and do some more experimentations to see if I can actually make this better. Some things I would do are improve the inlet port, use a clear bucket or semi-clear bucket so I can really see what's happening, and experiment with more of the distances and some of the shapes of things, just to see if I can get better results. And as usual, thanks everyone. Have a good day.